Hello and welcome back to Just Code It. Today we're going to be coding up an app that allows you to crawl a website and then chat with that website. On the right side of the screen, you can see the completed app. We can give it a URL, define some variables. So we have chunk size, overlap, the max amount of characters between full text search and using a vector database. I already said overlap, max pages to crawl, so max pages, and then the depth. Finally, we have just things in the URL that we should ignore, so like login pages and stuff like that. And you select your model and your embedding model, you hit process, scraping some pages, created the vector database, you can see the pages, and you can ask it a question. Looking at the completed app, let's get going on actually coding this thing. Back on the left side, we have the starter template where we have all these methods that we're going to slowly start filling out. I just have descriptions in them. And then at the very bottom, we have that main event loop. If you have all these functions and either a pass or some documentation in there, this will work. We'll start down here and create this main function. The first thing we want to do is initialize the session state. That's the top one. And then create the page config. These are just two methods. And then we're going to call the create sidebar config. Secondly, we're going to then create the button for clearing the chat and creating those two columns in the main interface. You can see the two columns right here where we're going to do the process web page and then enter. Finally, we're going to check to see if that button is pressed. If it's pressed, we're going to store the URL as a state variable. Then we're going to call the process web page method, which returns the query processor text length that we're going to check, and then the number of pages. After that, we're going to check to make sure the query processor is not none, just a sanity check to make sure it actually worked. We're going to set some state variables, which is going to be the query processor, text length, number of pages. We're going to set the chat history to null or empty list. Then the messages are going to be a list. And then we're going to add one message, which is going to be of the role assistant. The content's just going to be how many pages, just like a starter prompt. Finally, we're going to then do st rerun to rerun the app. Outside of that if statement, we then have an else there. We have an else, which shows a warning, please enter a valid URL. At the very bottom, we also have an if name equals main, which calls the main function, which sets this all in motion. Back to the top, though, to get started on some of these methods. I just created the first two because they're just boilerplate. The first method is initialize session state. Here, we're just checking to see if the session state contains these variables. If it doesn't, we set it. Here, we have message. If message is not contained, we then set it to none. Down to the setup page config. Here, we're just going to set the title, page icon, and then the layout. We're going to use wide. We're just going to do the title for the actual interface, which is going to be chat with website using LangChain and Olama. The first method that we're actually going to start filling out is the create sidebar, which it creates the sidebar. Let's allow always rerun. Here we created the sidebar, but let's walk through what we're doing here. If you saw the previous video where we just did a website chat, we didn't have the crawling functionality. We're going to first do with sidebar just to get everything to the sidebar and then do a header with configuration. This is where it's a bit different than what most people do, but I enjoy doing it this way, which is we set the config equal to a dictionary. Then within this dictionary, we're setting these keys in the dictionary to the actual element, the Streamlit element. So here we're setting Olama model to Streamlit select box and then giving it the select box. The reason I like doing this is because when you then pass this config out of here, you just have one object that you really have to worry about with all the config information. Moving down, we're just going to repeat this process for every setting on the sidebar. So we have the embedding models. We're passing it some embedding models. I use this one because it's super small and fast, and DeepSeek R1, the 1.5 billion one, because it's also super fast. Text threshold, this is the threshold. If it's under the value, it's going to do a full text search, this is a remnants of when we did it with a just single page chat. It'll probably almost always go to a vector database when it's a multi-page chat and scraping, unless you select max page to 1. You basically have the number of steps, so like how much it goes up, and then the value, which is the default value of 10,000. I believe we're using the recursive text splitter, which uses this chunk size to basically chunk it up. how big the chunks, and then the overlap to gain better context and not miss out on as much. Next setting is the max pages. Step of 1, we're going to start with just 5. Crawl depth, we're just going to start with 1 because we don't want to get too crazy with it. Then the exclude patterns. So this is a list of URLs and URLs that you do not want to scrape. So if there's a login, sign up, register URL, and it has it in the URL string, it will exclude it. Moving on to the web crawler components. The first one is just a sanity check. What I was saying was this validate URL. Basically, it's just going to check to see if we get an error code of 400. If it does, we're going to return the error. The next method we have is extract links from this URL. We're going to first start with an empty list called links. Then we're going to iterate and find all the links within this HTML. So this response is HTML. And we're going to find all the hrefs within this list. Then just join it to the full URLs. We're then going to parse it to get the domain using URL parse and then passing it the full URL. Before we add it to the links list, we're going to make sure that the URL is of the same domain as our initial domain. So the base domain that we pass in here. And if it is, we then append it. We're trying to just scrape URLs from the website that we initially started at so we don't start going to different websites and get lost. Next up, we have the exclusions, which just looks at the pattern, exclusion pattern, which is going to be the list of URLs. So it's going to iterate over those, look at each individual one, and see if it's in the URL. And if it is, it's going to return true. If it's not, it's going to return false. The next method is the actual crawler. It's not a very complex one because we're not using any third-party packages. At first, we're just going to grab some variables from the config, grab the base domain that we're going to be using later on, and initialize our tracking variables. We have our queue, visited, that's a set because we want to only have a distinct list. All text, we're going to start slapping text to the end of this from the different pages. And page counts, what page we're on, essentially. Moving down, we're going to do a while loop, while queue. So while there's still stuff in the queue and the page count is less than the max page count, we're going to do this process. So if we run out of URLs or if we hit the max page count, the first thing we're going to do in this while loop is grab the URL and the depth using queue.pop, popping one off the top of the queue. Then we're just basically going to check to see if that URL has been visited. And if it is, just skip and go to the top again. If we pass that, we then move down and add it to the visited list. If it's seen again, it will kick out. This is just a UI component to show that it's getting processed. The next component is going to be actually a Streamlit component that we pass in at the top. I forgot to go over these. So we're passing in the config, the start URL, the process bar, which is Streamlit component, and then the process text, which is also a Streamlit component. The process text is going to be if process text. So if it's processing, we're then going to show what page it's on. Essentially, we're crawling page number blank out of the pages, give it the URL. After showing that processing symbol, we're then going to do a try except here to basically catch any errors if there's errors processing the text. What this method does is, or what this section of the method does is it defines variable text, and then it uses another method, extract text from web page, and then passes the URL to get the text. After getting the text, it's going to check to see if it actually got any text. If it doesn't, it's going to basically kick and use that exception and return a warning sign saying error crawling, and then the URL and the error. But up here, we're going to then check the text. So if it exists, it's going to move on. And then we're going to take all the text and just format it and add it together. So we're going to take our old text, then slap the new text to it. So that's this plus sign right here. You can add text like that in Python. And after that, we're going to enumerate the page count. Moving down a bit, we got the update progress bar. This is the other Streamlit component that we created, which processes creates that other process bar. Next, we have another check that basically checks to see if we've hit that max depth. If we haven't, we then extract more URLs using the request get URL and then pass it the URL of the URL that we're processing right now. Get the soup, extract the links using that other method that we created, then appending those links to the queue. So if the queue runs out, or if you have multiple depths, every step it goes, it's going to keep adding links to the queue. The append here will then add it to the bottom. So we're going to take them from the top, add them to the bottom. You could also do a random list here if you wanted to just randomize it. The last thing we're going to do, just so you don't get throttled by a server, is you can add a time sleep here. Final step in this method is we're going to update that session state for the crawled URLs and then add the visited to it. The next one's a bit simpler. So this is the web processing component. What this method does is it's given a URL and then returns a string or none of the processed text, cleaning it up a little bit. But we're going to use that web-based loader and then pass it the URL, the data, which is at the first position, .page content, just returning this actual content of the page, not all the metadata. If the try fails, we're then going to return the exception, error loading, then pass it the URL and the exception. Returning none, which we check in the previous method above. The next one up is create full context processor. What this processor does is return the processor, which is a method. So we're returning it. And what we're going to do is create a prompt, which has the context and then the user input. Because we don't have any vector search here, this is pretty basic. Now we're going to move to the vector processor. Where is it? Here it is. It's going to return the same thing. It's going to return a processor. But the main difference is going to be within that processor. We're going to have a different method. So this processor query method is different within this one. Now you can see how changing this up makes it so we can pass the same method, but have essentially two different methods within one. We're going to create a response, which is our QA chain, which we pass in, and then invoke, create that prompt template. The chat history response text is response, and then the answer. We're going to take that answer and update our chat history, returning the response text. And within the processor method, we're then going to return the process query method. This is going to set up the vector database, chunk the text, and create those vector embeddings. Here we have the text splitter, which is going to use some of those settings. We're going to use the config chunk size for the chunk size and overlap for the overlap, creating that text splitter, and then we're going to use it to split our text, which is passed into this method, creating a bunch of chunks. Moving down, we have the embedding. This is our embedding model. Olama is what we're using, and then we're using, again, that config file, or that config variable, and then the variable embedding model. The vector store we're using is Faz. We can never pronounce that. Faz, I'm just going to call it Faz. We're going to use Faz, and then from text, pass it the chunks, pass it the embedding, we get the vector store. Finally, creating the retriever. So we're going to do retriever equals vector store as retriever. There's more settings that you can add to the retriever, but we're just going to say search keywords. K is set to 4. It's going to only return 4 similarity search results. Memory, we're going to set up some memory so it actually remembers what you're talking about in the chat. And we're going to use conversation memory buffer, pass it the chat history, a return message of true. It's going to return an actual message from this. Moving down, we have creating the LLM that we're using. Here we're using Chat Olama, but if you were using OpenAI, you would add this here, and then you can find other things like variables, like temperature. We're going to set a low temperature so it doesn't hallucinate. The question chain is going to be used later on, but what it does is creates a conversation retrieval chain from LLM and giving it the LLM, the retriever, and the memory. At the end of the method, believe it or not, we have a return that returns the chain. That is it for that method, and we're moving on to the next one. The next website, we're going to process the website. What it does is it crawls the website, essentially. We're giving it a URL and the config, and it returns a tuple with the processor function, and then the length and the number of pages. We're going to first set the text to Streamlit empty, process text to empty, and then process bar is going to be set to 0, so starting at 0. After that, we can then create or just add some text. Process text is going to be text starting website crawl, so this will not show up until you hit process. Let's reload this. Here you can see it going. It's probably going to error. Oh, it didn't error. All right, cool. Moving on to the with spinner. So this is that spinner that's going to spin when we hit that process. Crawling website, if we click it again, crawling website right here in the spinner. Text length is just going to be, we're just going to take the length of all the text Pages, we're just going to grab it from the session state, the crawled URLs, the length of that, add that to the process. Here we're adding the length and the text at the very end. This will show right here at the very end after it crawls them all. It might flash really quick. Oh, yeah, but it essentially just shows extracted X amount of characters and X pages, then shows a success message, which you saw just right there. The next thing we're going to do is define that LLM, which is chat olama. Moving on, we're going to then decide if we're going to use a full text search or vector embeddings using this. So if it's less than the config threshold, then we're going to use the full text component, which passes us the processor, where we then set the full text in the session state to full text, and then the vector approach is set to false. As you can imagine, the other side of this is we're going to then set up the vector approach, which returns the QA chain, then create the vector processor with the QA chain, setting a few state variables at the end. So full text is none because we're not using it, and vector approach is true. Finally, we're just going to reset that process bar and the process text so that if we then change the URL, it just clears it out and resets them. Turning the processor, the text length, and the number of pages from this method. Moving down, we have a display message. In this method, we're going to iterate over the messages in the session state. And with st message, we're going to then message and grab the role within that message, printing to the screen the st write to the screen the message content. Moving on to handling that user input. I believe this is the last one. The last method we have is handling the user input. With this one, we're going to do user input, st chat input, and then ask a question. If user inputs, if someone inputs information or adds a question, we're then going to add it to the session state for messages. We're going to append role. So that's what we're using up here to iterate over. So we're going to grab a role. The role is going to be user, and then the content's going to be what we print, but the content's going to be the user input. Moving down, we're going to display the user message. We're going to do with Streamlit chat message user, and we're write the input. Next, we're going to generate the response. So use that query processor. And this is where it becomes easy because we just have one query processor because we return those multiple different types of query processors. Inside of the assistant chat message, we're going to add a spinner, essentially just saying thinking, and it's going to say that until we get the response. The response text is going to be coming from the query processor. After we get the response text, it's going to then write it to the screen and kick out of this with chat message. We write the response to the screen and move on. The final step within this method is adding this assistant to the messages. So when we iterate over them, if they send another message, it will then print this message to it. So we're going to add it to the session state with the role assistant, and the content is going to be the response text. That is it. Let's hopefully see if it works. It will probably err on us, knowing me, but I think we have everything there. Let's test it out. Let's process it. Okay, it's going. I think we're missing a method. Oh, nope, we forgot to add a few things to the main function. So let's add those in. I think I kicked those out because they were probably erroring when we were running stuff. Let's add in the few other steps to the main method. What we're going to add to the main method is first we're going to essentially see if the URL or the crawled URLs are available and then show them in an expander, just showing all the URLs that we crawled. How we do this is we checked if it has an attribute. So we're going to check to see if this object, the session state, has the attribute crawled URLs. We're also going to check to make sure the session state crawled URLs is set. If it is, we're then going to show the expander with the crawled pages and then iterate over the crawled URLs and just print them to the page. Moving on, we're going to then display the chat message, which will display the chat message, as you can imagine. Finally, we have the handle user input. So if the processor is in the session state, we're then going to handle user input and show the user input. As you can see, with me not seeing, I reloaded the page. With it not being processed, it doesn't show the user input at the bottom. And now that we save this real quick, now that we have everything in, it should go through, process all the pages, show that, and then bam, shows the user input and the expander with the crawled URLs that you can click on. Finally, we can just ask a question, what is LangChain? And have it answer. Might take a second. Here we are. It gives us the answer to the question, believe it or not. That is it. If you want a bit of an easier app to start out with, I should have probably said this at the beginning. I basically have the same app, but just a single web page chat. So I'll put the link for it if I remember in the description. Also, if you have any questions, comment down below. I hope you enjoyed today's video, and I'll see you next time.